is now 10 minutes past 3, so we'll start panel session 3, supply chain enhancement. During this session, we will have presentations on various initiatives taken to enhance supply chain. This session will be facilitated by Kazuyuki Tada, who is the director of the Resource Energy or Nuclear Policy Division of ANRI. Thank you for that kind introduction. The theme of this session is the enhancement of supply chain, addressing specifically about improved safety of nuclear usage, the supply disruption countermeasures, and advancements. We'll first have short presentations from the panel members before we go into the panel discussion. We ask for your cooperation. We are a little behind schedule. So first, we will have Toru Okada from FEPC, Federation of Electric Power Companies, to give his presentation. He is the director of the Nuclear Division. Thank you. Thank you for the introduction. I am Okada from FEPC. I belong to the Nuclear Division. Today, I'd like to talk about the revitalization of nuclear industry for the future. I'll try not to repeat what's already been said. No, it's going to be repeat. Please bear with me. The 7th Strategic Energy Plan outlines a direction for a balanced power supply mix utilizing all available technologies, maximizing renewable energy and nuclear, and combining it with thermal and others with output adjustment capabilities to achieve both stable supply and decarbonization amid expected increase in electricity demand due to advances in DX and GX. As both nuclear and thermal power could significantly lose capacity in the future, as shown in this slide, we need to promote the replacement of existing stable power sources. To achieve the nuclear portion envisioned for fiscal 2040, we need to restart existing reactors, maximize their utilization, and work toward the development and installation of new advanced reactors. Regarding the restarts and review status, 15 plants have now restarted, added with Kashiwazaki Kariwa Unit 6 on February 16th. There are 15 restarted. However, many are still under review or have yet to apply for approval. 3 plants that have obtained installation permits, like KK7 and Tomari and Tokai Daini, work is underway for restart. As industry initiatives, FEPC established a Restart Acceleration Task Force in February of 2021. We aim to further accelerate restarts by establishing systems for personnel support, latest review information sharing, and technical support. As a specific example of this task force, in April 2025, we shared the knowledge and lessons learned relative to experience leading up to the restart of Shimane Unit 2 and Onagawa Unit 2 after long shutdowns. As part of our efforts to maximize the use of existing reactors, we are working to improve plant safety and quality by enhancing the plant operations. The 4 initiatives listed below will enable us to secure experienced workers and promote the transfer of their skills and expertise, leading to improved maintenance work quality and plant safety. Now, moving to discussing future replacement and reconstruction. And the future replacement, ensuring safety based on the lessons learned from Fukushima accident and gaining the understanding of local residents and other stakeholders are essential prerequisites. In deciding replacements by operators, it is extremely important for the government to set specific targets for installed capacity as part of the outlook and future vision, in addition to measures currently being discussed at government councils on business environment development and regulatory foreseeability. As part of efforts to improve regulatory foreseeability, as was shown earlier, Athena has held 7 technical opinion exchange meetings with the regulator on SRZ 1200, developed by 4 PWR companies and MHI. And a working group of the Atomic Energy Society of Japan is currently discussing BWRs as well, as was mentioned by a representative by MHI, or Toshiba rather. A report was published last December, and operators are participating in this working group as members. Kansai Electric is considering the feasibility of installing a successor plant at the Mihama site, including resuming voluntary on-site surveys. Given the expected significant decline in installed capacity, a concrete outlook and vision for nuclear is needed for continuous serial development and installation over the medium to long term. At the Nuclear Energy Subcommittee meeting last October, FEPC advocated that discussions on the medium to long-term outlook and vision for nuclear should start from the need for replacement of approximately 5.5 million kilowatts in the 2040s, based on the premise of steadily progressing further improvement of utilizing existing reactors in order to ensure a stable supply based on the demand projected in the Strategic Energy Plan. The scale of reconstruction needs to be indicated because the sustainable use of nuclear into the future requires an urgent rebuilding of human resources, supply chain, and technology that form the business foundation. It is essential that the government indicates the future scale and presents a concrete outlook and future vision for nuclear toward continuous and serial development and installation. I will only read the last bullet item. In addition to operators steadily promoting respective initiatives, we also will work with the plant manufacturers and suppliers participating in the nuclear supply chain platform to contribute to the development of the nuclear power industry. Your continued support and understanding is appreciated. And that concludes my presentation. Thank you.
Thank you very much. Next, I would like to invite Mr. Junichi Matsumoto, Director of Atomic Energy Association, Athena. This is Matsumoto from the Atomic Energy Association we refer to as Athena. Let me explain about our efforts. So this is what I cover today. These are the 5 agenda items. So first, let me explain the composition of Athena, Atomic Energy Association. So Athena is an organization established in July 2018 and operated by approximately 30 staff members who are experts in their respective fields in nuclear business. Member companies include Japanese nuclear power operators, major plant manufacturers, and various organizations within the industry. Staff members are also seconded from these member companies. Athena is an organization composed of nuclear power operators, manufacturers, and others with 3 primary roles. First, It promotes the introduction of effective safety measures by operators. Second, to engage in dialogue with regulatory authorities as a representative of operators. Third, it seeks to communicate with various stakeholders. Particularly regarding the first point, the review and implementation of safety measures, the aim is for the industry itself to demonstrate leadership and drive safety improvements. This slide outlines Athena's key activities with a mid to long-term perspective, safety enhancement, and proactive utilization of new knowledge and technologies, evolution into a trusted organization. So we have been implementing various activities based on these pillars. Among the examples of activities expected to benefit our suppliers that will be explained below, like implementation of online maintenance initiatives towards introducing innovative light water reactors. And those are the high priority initiatives. So today we want to show you some examples of LM, innovative light water reactors, and also discontinued product management. So the first example of an activity is discontinued product management, which is already operational. So discontinued products refer to items where plant manufacturers and suppliers face difficulties in maintaining design and inspection expertise, leading to the discontinuation of parts and services. Athena proactively addressed the issue by publishing the End-of-Life Product Management Guideline in 2020. According to Athena Guide, operators have established end-of-life product management programs and built a collaborative framework to proactively share end-of-life product information through the BWR-PWR Operators Liaison Group. We have provided 2 examples of discontinued product management. By systematically replacing products with alternatives, we help maintain suppliers' development and supply capabilities and continuous transfer of technology so we can support development of successor models. The second example of activity is online maintenance, which has reached the stage just before actual implementation. Online maintenance refers to performing equipment maintenance while the plant is operational, shifting this work from the scheduled inspections traditionally conducted during plant shutdown. Therefore, implementing online maintenance enhances plant safety by avoiding work congestion during the scheduled inspections and enabling optimal allocation of skilled personnel through workload leveling throughout the year. This also helps prevent unplanned shutdowns caused by issues. Furthermore, by leveling the workload throughout the year, we believe it enables the effective utilization of supplier resources and facilitates the transfer of technical expertise. Based on this perspective, a working group has been established within Athena to conduct studies during the introduction of online maintenance. And let me talk about the verification on the floor in line with the introduction of online maintenance. To identify challenges and improvement points, field demonstrations were conducted at actual power plants twice at Ikata and once at OE during fiscal 2025, with discussions held with new NRA. In each demonstration, by implementing risk mitigation measures, we were able to conduct online maintenance while ensuring both work safety and plant safety. Furthermore, the field verification confirmed benefits leading to improved maintenance work quality. It also confirmed the expected effect of enhancing plant safety from the perspective of reducing equipment failure risks. Regarding online maintenance future outlook, as mentioned in the previous slide, since the same procedures demonstrated in the 2 field tests at Shikoku Ikata and also in the previous, also at OE as well. So basically, we identify no new issues. Therefore, we are discussing with NRA so we can start implementation in the fiscal 2026. Moving forward, by widely implementing online maintenance in actual operation in Japan, we can level the annual workload across plants to optimize supplier resource utilization and enhancing plant safety, improving transfer of technical expertise. And the third example is our future-oriented initiatives to introduce innovative light water reactors. We believe this initiative will lead to the creation of new employment opportunities for suppliers by enabling the future replacement of existing reactors with innovative reactors. But innovative light water reactors incorporate new technologies in design, distinct from existing light water reactors. So when compared against current regulatory requirement, they present areas of uncertainty. So we have held MHI and the 4 power utilities are currently working together to develop SRZ 1200 innovative light water reactors. And we have held total 7 rounds of discussions with NRA using this as a major example. And the points of discussion will be reported to NRC, the nuclear regulation NRA. The NRA views are expected to be presented soon. And since the establishment in 2018, Athena has been engaged in activities to lead and promote autonomous and continuous safety improvement within Japan's nuclear industry. And so we will continue to lead the industry. So we will continue to contribute to the sustainable use of nuclear power. Thank you for your attention.
Thank you very much. Now I would like to invite Ms. Ayako Suzuki, General Manager, Nuclear Production of Hitachi GE Vernova Nuclear Energy. Thank you very much for your kind introduction. This is Suzuki from Hitachi GE Vernova Nuclear Energy. I'd like to discuss CGD, commercial grade dedication, how it's going in Japan as part of the effort to enhance supply chain. So this is about the environment around the nuclear supply chain. As you can see on the left, after the 2011 accident at Fukushima Daiichi, the BWR restarts and construction took a lot of time before they were resumed. And so maintenance of equipment or manufacturing opportunities were almost decimated. And so the suppliers, technologies, availability, skills set were very difficult to maintain. And there's an increase in suppliers who are reducing their operations or even withdrawing. As a result, so those are the challenges. And on the right-hand side, the industry is working on various efforts like partnering with the suppliers, developing alternative suppliers, and also considering the possibility of CGD, commercial grade dedication. And so it's the CGD that I'd like to focus on today. So first, what is CGD? So traditionally, for nuclear items, the suppliers would need to be responsible for the quality, assuring the quality for the nuclear items, but you need a lot of documents, a lot of inspections, records, identification, and manage all that. So that was a great burden on the suppliers. But CGD actually allows for the suppliers to just continue their usual commercial grade quality control, and nuclear QA will be performed by the purchaser. So this is meant to reduce the burden on the suppliers while maintaining the availability of components, materials, and therefore address the obsolescence challenge. So this is the CGD process. So you start with the identifying safety function and the critical features, and select your verification method, and then conduct that evaluation and certification. For example, if you look at the manual valve, the safety function can be separated into the operation, isolation, and withstanding pressure. And then you identify the identified features. So if it's valve operation, operability, dimensions are the key features or properties. And then those could be checked by witnessing, testing, or inspection. You choose the relevant one. And then the results of that verification will be recorded so that the safety function can be assured. And so efforts to expand CGD. On the top, we are showing the supply chain related organizations and their needs and their challenges associated with CGD, and together with what efforts are underway to address that. So the plant manufacturers, the guidelines may be unclear. There's little experience or cases or precedents. And so addressing that, the METI is supporting the activities to draft a guideline, and we've also conducted a demonstration of the process. So we are actually trying to address that. On the utility side, the challenge was that the process was not widely known and accepted, and we also needed to verify the process and the viability. So we needed to try to raise the awareness. So we conducted briefing sections. We also ran trial projects to verify the utility processes so that we can actually supply those commercial grade items. On the supplier side, we need the suppliers to be better aware that CGD will allow for them to continue to supply to the nuclear industry, but there was a low appreciation or awareness of that. So we need to obviously communicate that better and also build cases so that they can build on that with confidence. So I'd like to particularly focus on how we built that process, have we tried to raise awareness, and how we actually tried to build real cases. So first, developing the process. We have been working with Toshiba Energy System from 2024 on an METI-funded project. And what we were doing is we actually demonstrated using the CGD process, which involves the design change, so as to try to rationalize the documentation, etc. We actually used the actual O-ring for which supply was lost, and we actually used commercially available O-rings domestically. And then with regard to awareness raising, we worked with the GEMA working group, and we conducted joint explanatory sessions. We also actually visited the utilities, and we, for example, are here to discuss this, and we've also communicated in various ways towards the utilities as well as suppliers. We also attend the business partner exchange events or any opportunities to deliver lectures or deliver poster presentations. We're also working with Chubu Electric, and we are particularly trying to focus on the chiller oil pump motor to verify the CGD process, identify challenges, address and identify the countermeasures so that we can actually build a consensus as to how exactly CGD can be conducted. And so CGD is about the purchaser qualifying commercial grade items and using for nuclear. So that will help reduce the burden of the suppliers and avoid obsolescence issues. But Japan, we need to build awareness and actually build cases. So Hitachi Belnova is working with METI utilities, manufacturers, suppliers to build the process, raise awareness, and build cases. We will try to focus more on building real cases so that this can really take root. We'll accelerate our cooperation with the utilities, and we hope to continue with the government agency as well. Thank you very much.
Thank you very much. We now move to Mitsuru Ino of Taihei Dengyo. He is the director of the construction headquarters and also of nuclear management. Thank you for the kind introduction. My name is Ino from Taihei Dengyo. I'd like to talk about what we're doing to develop human resources related to nuclear power within our company. First is the business overview of the company. We have 1,903 employees within our group and 7,000 partner company employees working at sites across the country. Greater strength is our ability to quickly build a comprehensive, strong system based on this nationwide human resources base. We have been involved in nuclear power for a very long time, and our history has progressed alongside Japan's energy development, beginning with the installation of JRR-2 experimental reactor at Tokai Research Institute in 1958. We have been involved in the construction of approximately 70% of Japan's nuclear power plants. Our construction track record. We have a track record in carrying out a range of construction work throughout the life of nuclear power plant, from construction to decommissioning. We have been involved in construction work since the late 1950s, the dawn of nuclear power generation, and have been involved in approximately 70% of the work. In terms of the inspection and outage work, we have offices at 12 different plants. And this is the company's record in workforce deployment. Due to a declining following the 2011 earthquake, there was a period when number fell below 1,000, but currently we have about 3,000 people working. Next is our human resources development program. There are two major challenges: the industry situation and the uniqueness of the job. The industry as a whole is in urgent need to technical skills transfer. So to solve these challenges, the company is focusing on training three job types: next generation engineers, radiation control supervisors, and welders. First, regarding the training of next generation of engineers and technicians, construction of next generation reactors is expected in the 2030s, and the company has not undertaken any new construction work since 2008. Currently, the number of employees with construction experience has decreased to about 40% compared to that time. So how to pass on the construction techniques to the next generation is a major issue. To address this, we have three pillars. One is to maximize the practical experience through on-the-job training. Large-scale modification work, such as the replacement reactor internals, is scheduled at many power plants between 2026 and 2035. So this will provide an opportunity to gain experience handling heavy equipment, and we believe it will be a valuable experience for our trainees. The second pillar is the specialized off-the-job training. We conduct practical training using mock-ups at Wakasa Bay Energy Research Center at the facilities and at the facilities of utilities. And this has proven to be a very good opportunity to gain experience. The third pillar, we plan to ensure that the construction structure itself functions as a platform for transferring skills. We intentionally pair young and mid-career employees in their 20s and 30s, so as to have them play key roles. And in terms of training, the radiation control personnel, the issue is to get the qualification. So we are taking three measures. First is pairing veterans with the younger personnel to strengthen on-the-job training. Second is providing on-the-job training at outage offices. Third is to provide support for obtaining difficult qualifications by encouraging workers to participate in workshops and others. I also would like to talk about the human resources development for welders. We have approximately 60 welders, including employees and trainees, and we are hiring new employees every year. And the developing welders takes several years. So we are providing a gradual step-by-step training. Intensive training in the first and second years of employment allows employees to acquire basics and JIS qualification. And then in their third to fifth years, they move up to more advanced qualifications. I also would like to talk about creating an environment for building nuclear infrastructure. Environment needs to be established for the industry overall. There are three things which I think is important. First is the establishment of mock-up training facilities for next-generation reactor construction. Currently, we only have facilities for regular outage work. We need specialized facilities. We believe that mock-up training facility for next-generation reactors is needed. The second is the sharing and centralized management of individual reliability confirmation. Currently, individual needs to be examined on a utility-by-utility basis. If this information could be shared, then I think we can reduce lead time, as well as improve the efficiency. The third is the standardization of welding qualifications and construction methods for thermal and nuclear power plants. Currently, those are the same in terms of substance, but the systems are separate. If we can unite them as a single system, I think that would contribute to improving the efficiency of the welding qualifications. At Taihei Dengyo, we are actively working to train and secure technical workers. His numbers are declining. We intend to contribute to building a resilient nuclear supply chain in anticipation of increase in outage work. And with that, I conclude my presentation. Thank you very much for your kind attention.
Thank you. Lastly, I'd like to invite Mr. Junji Eto, Senior Researcher at the Infrastructure and Urban Policy Division of Mitsubishi Research Institute. This is Eto from Mitsubishi Research Institute. And let me talk about the improvement for the access to the plant. So this is actually conducted as part of the project by the Ministry for the Nuclear Industry Infrastructure Strengthening. And let me start with the background and purpose, and this is what I will cover. So the access to nuclear power plants, and let me talk about the background and purpose. So at the time of periodic inspections outage, many workers enter and exit simultaneously, sometimes causing congestion of personnel and vehicles during entry and exit. And in fact, workers have expressed concerns that it could take about an hour to enter the site, and they wanted congestion reduced. And even so those who have an experience working at the site must have experienced this at least once. So based on this background, so we decided to analyze the current state of site access while maintaining security to see possibilities for improvement, especially as we see a worsening labor shortage. Improving efficiency in site access could help secure working hours, potentially leading to more effective personnel utilization and supply chain strengthening. So this is the overview of access to nuclear power plants. As you see left top, you have to go through pre-entry procedures. So you have to get the ID card and permit. Also, you have to get permit for your baggage. So you need to go through various preparation procedures. On the day of the work, at the front gate, you go through the baggage check or vehicle check if you go there by car. And after going through the front gate, main gate, then at the depending where you're working in a building, nuclear reactor building or in a surrounding location, you will need another ID card, and you have to go through metal detector. And also, you're going to have to go through some biometrics certification or going through the explosive inspection. So to work in a nuclear power station, since it's protected in multiple layers, so in order to operate a nuclear power station, a nuclear substance protection is essential, and it has to be maintained at a high level. So when we looked into potential improvement, first, we focused on entry and access to the power station and conducted analysis in details. At the power plants, you could access by car, by buses, or by taxis, and many other transportations. When you enter the power plants, the vehicles are checked. Also, the baggage and cargo inside vehicles are confirmed as well. If you come in buses, you need to, they will check your ID card. Also, check the personnel as well as checking all these baggages that were carried. Especially ID check and the baggage check are taking long time. So it could well take about an hour just to enter. So there is a possibility of improvement for site access, we thought. So as we identify the possibility for improvement, we try to calculate the time on the current and versus after implementing technology. And so we assumed the actual power plant starting at 8:30, and the peak entry would be 7:30. So we try to use the normal distribution before and after 15 minutes, and assuming 2,000 people or the 200 vehicles assumed in calculation. A normal power station tend to have 4 lanes for vehicles, and for ID check, baggage check, there are 5 lanes. So we use these conditions as a calculation and compare it to the actual situation. First, we confirm there is no major gap between our calculation and actual situation. Then we wanted to calculate the reduction after implementing technology. So possible technologies could be utilized for site access. As you see in the right top, for vehicles, we could use cameras to do the image ID confirmation to check the appearance. For people access, for baggage check, we can use AI equipment. For X-ray check, for the ID check, will be the facial recognition technology. So these could be quite effective. And this is the actual comparing the time needed for the current situation versus after the improvement. The top one, vehicle confirmation, it's taking 40 minutes. But basically, no waiting queue will be created after the change. So 40 minutes can be reduced. For the baggage check or ID check, currently it's taking 60 minutes and 30 minutes respectively. With introduction technology, we can go down to 20 minutes and 2 minutes respectively. The biggest bottleneck, the baggage check, we can reduce about 43 minutes. So that's the result of calculation. Next slide is for your reference. This is the distribution of waiting time of 2,000 people, and we were able to see a huge reduction in the waiting time. So we are having all these technologies available, but we may have some bottleneck in implementing them because safety, reliability is quite important from regulatory perspective. We're going to have to actually get approval by reviewing by the authority. But by sharing the process, and we should not be able to face any major hurdle. So at the planning stage, we can calculate the cost and the efficiency, and by selecting the right, the reliable technology, and we can avoid the major construction timing, and we can introduce in a planned manner. That way, there's no need to address any bottlenecks. And AI quality, how the nuclear industry is looking at this AI quality. So properly communicate the requirement and also to be able to confirm accomplishment in a smooth manner. Those are mentioned in the guideline at this point in the industry. So we need to maintain strict security, but if we could reduce the time for site access, we should be able to be efficient in using human resources under the shortage condition, and this can actually lead to much better evaluation of industry itself, and we can further see the improved reliability and efficiency. So the use of AI and digital technology can be a good, effective method for us. Thank you for your attention.
Thank you very much, and thank you everyone for really compressing your presentations within time. So I'd like to now proceed to the discussion part. And my first question goes to Matsumoto-san from Athena. So we heard about supply chain enhancement and leveraging the existing reactors and replacement, and those are very important. And the government has a strong expectation, very high expectations. But what do you have about what is the outlook going forward? Thank you very much. With regard to online maintenance, we have done 3 rounds of demonstrations, and we have confirmed that there are no major challenges, and we are continuing our discussions with NRA to prepare for that. Going forward, we believe it's important to build a strong track record, and through that, we should run the PDC cycle. And with regard to the what should be covered by our online maintenance, and that's related to AOT. And so we are also trying to discuss how we can possibly extend the allowable outage time. And with regards to the obsolescence, all the utilities and power companies are actually addressing this as part of their existing maintenance activities, and we will continue to share information with that and try to be proactive so that we don't face a situation where we can't get what we need. Thank you very much. Now I'd like to ask Ino-san from Taihei Dengyo. In your presentation, Ino-san, you talked about something that I hadn't really realized as a challenge. For example, the welders, there are so many qualifications, I didn't know that. And you also talked about different processes that you go through for access into the site or into the protected areas. And so there were a number of improvements suggested, particularly from Eto-san of MRI. He suggested how we could expedite the access control and PP process. Any observations? Yes, thank you very much. Obviously, rigorous security check is in place, and it takes time. For example, if you are going into access protected area or protected area, so there's always a queue. Usually, if you are going through an outage, you will probably take 30 minutes at each checkpoint. And if it's more construction related to the new regulatory requirements or the specified safety facility, then you could actually wait for 1 hour. We are trying to alleviate that by staggering the work hours, etc., but it's still a really big burden. And so the analysis done by MRA does fit our real feeling. And the MRA presentation talked about this advanced system, so maintaining the level of security but reducing the queue, and we have very high expectations of that. For example, if we could actually extend the effective work hours by an hour every day, that will definitely improve the work efficiency. It also reduces the exhaustion on the part of the workers, and it's really certainly motivating. With regard to new technology introduction, obviously it will take some time. So for the time being, we hope that we can see improvements other way. For example, you can have more lanes for baggage checking or have more security officers conduct a check, and that could improve the situation. Thank you very much. I've also visited sites, and yes, I would agree that there would be long queues sometimes. So working on that to improve that is very important, we think. And MRI proposed this new technology and the analysis. And the analysis actually showed some benefits, potential benefits. I'd like to hear the view of what that means for the industry. Yes, I'd like to take this opportunity to thank the utilities and the contractors for supporting us in conducting this analysis. So we actually interviewed them, we heard with their voice, and we're also happy to hear that Taihei Dengyo also thinks that's the case. In Japan, we are depopulating, and we will need to have quality engineers and technicians that work at the nuclear power stations, and it's a competition to really get quality human resources. And retaining that workforce depends largely on having the right and good work environment. As we heard from Taihei Dengyo, all the companies are investing a lot in human resources training. So once you've trained them, you would obviously want to retain that precious resource. And according to our analysis, one lesson or one outcome is that resolving that issue related to access control is also helpful for PP, physical protection. It's also about improving the working condition for the workers as well as the security officers, and it also helps to secure the human resources. But then if you want to resolve that, we will really need the utilities to take the lead. So maybe one way to go is for the whole of the industry to really work together on this. I think that's indeed very important. Thank you. Thank you very much. Yes, with labor shortage, we will probably want to look at various improvements. It's an improvement to really listen to what the people working in the field have to say. Thank you very much. So I'd like to ask Okada-san from FEPC. So we heard from the Okada-san from Taihei Dengyo and Eto-san from MRI. Any observations from the FEPC side, please? Thank you very much for that. With regards to the human resources development efforts at Taihei Dengyo, I am very impressed. And so the construction related to the new regulatory requirement and large construction, and also they are also using this for succession planning. So we're really happy about that. With regard to new plant construction outside, sometimes the delay is caused by low quality construction work. So that again means that it's very important to have very high quality workers so that the quality of work is high and the work is done in an efficient way. So that would actually help meeting the schedule.
And towards the end of Taihei Dengyo's presentation, there was a list of various issues pertaining to the environment for the infrastructure development. And I think the industry-wide collaboration would be needed. So as FEPC, we do see the need to have that kind of collaboration. For those projects, the ANRI's Council on nuclear human resources development should be a forum for discussion. And as was explained by Taihei Dengyo and MRI, as for the issues pertaining to the physical protection, I think addressing this will translate into improved working environment for the actual workers on the ground. And yes, there is a possibility of using artificial intelligence and other digital technology, but it is important that we ensure that the quality of physical protection is maintained. So I'm hoping we can work together in addressing the issue. I have another question for Okada-san. Suzuki-san of Hitachi GE Vernova talked about the CGD and related issues. What do you think on the part of FEPC? Thank you. Since the Fukushima accident, it took us a long time to restart. And because of the uncertainty in the future of nuclear industry, the supplier companies were faced with the issue of how to retain technology bases and human resources. Some have decided to withdraw from nuclear. So industry as a whole need to work together to enhance the foreseeability of the businesses towards the development and installation of nuclear, the new generation reactors, as well as maximum utilization of existing facilities. And as for the CGD itself, as was explained by Suzuki-san, there is a JEMA guideline, but process has yet to be disseminated. And Athena representative talked about the demonstration, verification of OLM, and we need to combine those two so that people can gain the success cases. And I think there are issues that will be identified only when the actual commercialization is implemented. So on the part of the industry, the operators, we will be working together with the suppliers to address issues one at a time. Thank you. A question for Suzuki-san of Hitachi GE Nova. Okada-san of FEPC just indicated FEPC's willingness to collaborate. Any comments? Thank you. Plant manufacturers like ourselves have been collaborating with utilities to address the obsolescence issues. And most of the measures taken so far has been what's called the last buy. In other words, buy before they go obsolete. So what could be promising going forward is to further expand the use of CGD in the U.S. After a TMI accident, there was a long time where there were no new constructions. And so supply chain disruption and obsolescence issue was experienced by U.S. industry ahead of Japan. And U.S. adopted CGD early on. So I think that could be a good model for Japan to use CGD as one measures against obsolescence. But we need the cooperation of utilities to do this. So this, again, will require an industry-wide efforts. Thank you. There are many other questions I wanted to ask, but I'm afraid we ran out of time. So let me just give you the final comment. Enhancement of supply chain is the theme of the session. Listening to your presentations, there were three things that caught my attention. First, conventional approaches should not be taken as a given. Rather, improvement efforts would be necessary. That's point one. Point two, the industry-wide or cross-industry efforts are needed. And there are areas where the actual application adoption is already taking place. So we need to learn from those experiences. And we also make sure that we get the feedback, input from the supply chain manufacturers. The third is the great roles to be played by the government. As Okada-san said, the foreseeability needs to be established so as to enhance the supply chain. Discussion is currently underway at Nuclear Subcommittee, and we're hoping that the perspectives presented at this session will be incorporated in those discussions as well. Thank you.
Mr. Tada, all the panelists, thank you very much. So, Mr. Tada and panelists are now going back to their seats. Please also give them a big applause. Thank you so much. So before moving to session 4, we would like to take a 5-minute break. Session 4 is going to be starting at 4:10, 10 past 4. Please be seated by that timing. Thank you. So now we're starting the panel session 4, ensuring nuclear human resources and initiatives to develop those resources. And in this session, we will share the initiatives taken in an industry related to human resources for discussion. And this panel session will be also led by Mr. Tada as a facilitator from the Nuclear Energy Policy Division at the Agency for Natural Resources Energy. So in this session, the title Initiatives for Securing and Developing Nuclear Human Resources. So we'll focus our discussion on human resources. So we'll also have the NRA member here today. It's quite rare to have both NRA and also the NRA at the same table. So we hope to be able to have a good discussion. So before starting this session, I'd like to briefly introduce the initiatives and ongoing discussion within the METI, and let me explain on this. So this is, as you already know, and so we have already recovered the sales before COVID level. However, the investments pretty much halved since after the accident. And so there's no handover taking place for continuous orders. So we haven't been able to secure enough resources, especially at the contractor level. They've been having problem. The large plant makers are accelerating their hiring, but there's a change in the structure of the human supply. And so that this is going to be the overall industry-wide issue. So we need to take actions right now for the future. This is for your information. The cost overrun in overseas construction project are basically driven by human resources in supply chain. So we need to make an advanced investment for not repeating the same situation in Japan. There are many different players taking various actions related to reviewing related to nuclear industry resources, but there's no cross, the overall actions taken at this point. So that's why METI would like to take a lead. So we have started the organization committee to reinforce human resources in last September. So that way all the stakeholders related to human resources can actually have a discussion and share the issues. And we held 2 discussions already, and we're having a 3rd discussion in the near term to summarize the discussion. As you see in the red boxes, so we want to focus on those who are joining in industry, and also in the green boxes, those are the candidates who are to go into the industry. And for those who are already in the industry, especially supplier, construction company, and also the maintenance suppliers, we haven't been able to approach them yet in green area. For the industrial high school, the normal high school, also technological colleges, and all kinds of different educational institutions will need to be covered as well. And regarding the human resource development, and different parties are taking different initiatives, but we also need to share the same goal so we can set up the policy together between private and public cooperation, and so we can follow up the focus areas altogether in overseas market. And the industry association is leading this initiative to be able to consider the whole life cycle of nuclear facilities, and setting up the policies between public and private cooperation. So we want to take the same type of actions in Japan, and we are looking into this direction right now. understanding current conditions, supply-demand gap. This is example from France. And looking at their forecast, the GFEM, the French Association, is actually conducting hearing interviews and conducting surveys within the industry to understand what the resources are, what is their plan for the future. So they calculated how many more will be needed. In Japan, here, so we also got the forecast of the supply-demand situation. So we want to understand our view first. Then we categorize what's needed. And we want to understand the current situation of each professional, so we need to go into detailed analysis of the needs, resource needs. And this is the command center function example in France. So government, as industry, labor union, all together are forming the CSFN committee. And they're looking at the overall nuclear industry, and based on working with GFEN and EDF, and those industry players are actually following the CSNF's policy. So we want to also use that as a reference. We want to set up the command center so we can have more communication among those three categories, and we can set up the midterm plan, looking ahead the future trend, so we can follow up the plan for execution. Human resource initiatives, we want to work on more details to come, engineers and skilled workers, also nuclear resources, and we need to approach potential candidates for those professionals. And lastly, this is a summary. For the human resources to support our nuclear business, we need to actually rebuild in a sustainable framework, and that's where we are at now. And all the stakeholders from academia, government, and industry will need to share the vision, and necessary resources should be put so they can take a lead in each individual roles. And also, we will also need to execute the actions to develop human resources across the different industries. So we would like to take in your feedback as well so we can move on to the policy. Thank you for your attention. And next.
I'd like to invite Mr. Koji Aribayashi from the Ministry of Education, Culture, Sports, Science and Technology. He's the Director of Nuclear Energy Division.
皆さんこんにちは。文部科学省で
Good afternoon. My name is Aribayashi. I'm from the Atomic Energy Division of the Research and Development Bureau of MEXT. I'd like to talk about how MEXT is addressing this issue of human resources for nuclear industry. So we are working closely with the higher education, universities and colleges. And as you can see here, recently in the university or higher educations, there are fewer courses or departments offered, or there could be fewer students enrolling, or fewer in the teaching faculty, or the facilities used for the training and research are also, or education research, are also coming down. So it's becoming more and more challenging for one single teaching institution or a higher education institution to provide one through training. So we actually conducted a feasibility study, and after that, from FY 2021, we organized this consortium where different institutions actually offer different resources, and we organize that collectively. We call that ANEC, that's the Advanced Nuclear Education Consortium for the Future Society. It's a 7-year program all the way to FY 2026. And you can see on the table, or actually on the table, there are 4 focuses for us. So one is about structured specialized online courses. So all the universities and colleges across the countries are offering courses so that there can be comprehensive lectures and courses offered. So, like good lectures, we actually film them, video them, and this is hosted by the Hokkaido University, and it's on their server so that the college students everywhere in Japan can actually access and view those lectures. And the website actually organized those in different modules and lectures, like if you want to study about neutrons, it's like that. And so there are 105 such lectures that are made available, and each is actually viewed by about 60,000 students. students. And it's not just used by college students. Businesses are also using this to train their new hires for their foundational training. And then on experiments and hands-on experience and lower availability of those facilities for hands-on experience. We're also trying to offer international learning opportunities, again, by having those different higher education institutions coming together. For example, with regard to research reactors, Kinki University and Kyoto University have them. And so we are trying to use these facilities not just for the students learning at those institutions, but anyone who's studying nuclear energy and nuclear engineering, so that they can get training. They can also get hands-on experience at those research reactors. Then the right-hand side shows international learning opportunities. For this one, Science Tokyo is taking the lead. And so they are the host, and they will actually offer opportunities for students willing to get international experience. And the teaching faculty will organize tours for those students, or they would also invite students from other countries so that they can have an exchange opportunities. And then the fourth pillar is the co-creation across industry and academia. We're working with MHI. So looking at the whole chain of building a nuclear power station and actually operating them. So this has been running for 3 years, and more than 20 colleges and universities have sent their students. And the satisfaction level is 100%, and more than 90% of the students who actually enrolled are very interested in joining the nuclear industry. And 1/3 of the students were actually specializing in non-nuclear fields. So that's about ANEC and the 4 pillars of ANEC. And we are trying to evaluate how that made a difference. And so we asked those students how they actually, what type of jobs they actually found. And we found that 70 to 60% of the students who enrolled either continued education in the nuclear field or joined the nuclear industry. And as I mentioned earlier, ANEC is about different universities offering different resources and sharing that. The number one challenge is the physical distance. Because this college student may be studying here, this person may need to travel there. And currently, the Mixed is providing some assistance, financial assistance, to fund that travel fee, so as to allow for the students to travel and get hands-on training or join this international tour. But the MHI program is really great. And as I said earlier, the current ANEC is a time-limited program and will come to an end in FY 2026. So the question is what to do from FY 2027. And we believe that it is all the more important for us to partner with the industry. And therefore, we are trying to find a way to expand what we are already doing with MHI. We are mulling various options at this point in time. For example, different companies could, and as we heard in the previous session, there are various initiatives that are already taken. And so the training programs and training facilities, if they could actually allow part of the availability to be offered to college students, etc., we could use the ANEC network across those institutions, so and maybe send some of the students to get some training at one of the members of the nuclear community. So for the students, that will be a great opportunity to really have first-hand experience on what they learning means in the real world, and it could be actually an opportunity for the businesses to develop closer ties with the universities and colleges, which would be the source of their future workforce. So this ANIC business the current one will come to an end in FY 2026. Toward the post-ANIC or the next round, we are trying to get input from various people. So if you have anything to say, please utilize those websites and let us hear your views. This will be open for about 2 or 3 weeks from now. We really want your input, feedback. And so if any of you here from the industry have anything to say, please let us hear your voice. Thank you.
Thank you very much. We now move to NRA. Keiichi Watanabe, who is the director of the Personal Division of the Secretary General's Secretariat. Thank you for the kind introduction. I'm from NRA. I'm a Personnel Division Director, Watanabe. Thank you very much for inviting me to this symposium. Thank you, Tanaka-san. I would like to talk about the human resources development for nuclear regulation. First, I'll talk about the issues related to the personnel for nuclear regulation. And secondly, I'd like to explain to you what we are doing to address the issue. And in closing, I would also like to talk about how we are to pass on the lessons that we learned from Fukushima accident. First, the profile of the personnel needed for nuclear regulation, which is really wide-ranged. Regarding the restart of plants, screening review, that's making headlines. But in addition to that, we are involved in many other activities. For example, the safeguards. To implement these activities, not only nuclear engineering, but other physics and engineering discipline would be needed, as well as communication and other expertise. Nuclear really requires comprehensive knowledge and capability. As for the mission of NRA, protect people and environment through trusted nuclear regulation. There are 5 principles of our activities, not just for the organization, NRA, but for all the individuals working at NRA. The current situation. On the left-hand side, you can see the different age groups of people working at NRA. We have about 1,000 people, and 50% are over 50 years of age. So we need more younger people. On the right-hand side, you can see the breakdown of the new hires. Somewhere between 20 and 50, we really need to hire more engineers. With that, the direction of human resources development are threefold. One is expand, second is train and develop, and third is collaborate. First, we need to expand the basis of human resources. We do have a project for nuclear regulation personnel. Subsidies are being provided to train necessary personnel. There are 22 projects currently, and some are related to nuclear plant regulation, but we don't have many projects in that category, so this is where we want to enhance. And the projects include sending our personnel, staff members, and commissioners to lecture programs. So we really want to expand and enhance this type of projects. Second is the development within NRA. there are various jobs that requires qualification, like inspectors, reviewers. For younger people, they are to choose 2 out of 5 categories to go through a 1-year program. So they just spend 1 year solely on education and training. And through the on-the-job training, they are to be more skillful to become leaders of a specific area. And for the mid-career hires, based on their prior experience, we do provide qualification. Still, internal source could only go so far, and therefore we need to collaborate with the outside world. In the IRRS mission of IAEA, conducted very recently, it was pointed out that through multi-year human resource strategy, NRA can ensure that it maintains the specialized expertise required for independent and future regulation. And IAEA also pointed out that the government can support in this regard. So we have to take into consideration various aspects, not to invite suspicion from outside world. We need to maintain independence, but we want to collaborate as much as possible so as to broaden and deepen our personnel. And we are also hiring people with practical experience. We do this twice a year in May and September. Electrical engineering, civil engineering, these are the areas where we need more people. So those of you in this room, I would appreciate it if you could consider taking this opportunity to become the NRA personnel. Before closing, I'd like to talk about the need for us in the nuclear field to make sure we pass on the lessons that we learned from Fukushima accident. It's been 15 years, but we still have a long way to go in terms of decommissioning and everything else. At NRA, we don't have many work that is directly related to Fukushima. Decommissioning and the monitoring in the adjacent areas are just about the only things that we are involved in. So there is a risk that we may forget about Fukushima. So we make sure that our staff members visit Fukushima as much as possible so that they can retain the lessons learned and the memory of Fukushima. We believe that is the most important principle in our HR development. Thank you.
ありがとうございました。続きまして、
Thank you very much. So finally, so Yuko Wada to present us first. From the Japan Atomic Industrial Forum. I am Wada from Japan Atomic Industrial Forum. So today we want to talk about this initiatives to promote public understanding and secure develop human resources. This slide shows the overall structure of JEF activities. To enable maximum utilization of nuclear power, we focus on 3 pillars: promoting public understanding, human resource development, and international cooperation. Among them, today I will mainly introduce our initiatives aimed at fostering understanding among the younger generation, as well as our efforts to secure and develop human resources. This slide outlines our initiatives for building understanding and securing human resources. We organize them into short, mid, and long-term efforts. The short-term initiatives target students who are currently seeking employment. The mid-term initiative target university and tech college students. Long-term initiative target junior high and high school students, as well as their teachers. In addition, we are also reaching out broadly to the next generation and the general public. And we are implementing these initiatives in a systematic manner. And let me introduce some of the main activities in each category. First, this is short-term initiatives. JIFE organizes a joint corporate information session called the Nuclear Industry Seminar every year in Tokyo and Osaka. Last year, we also held a seminar in Fukuoka for the first time. This is a job hunting seminar specializing in the nuclear and radiation industries, and it has been very well received by both participants and participating companies and visitors. This slide shows the results. The green line represents the number of exhibiting companies, and the bar chart shows the number of visitors. In recent years, the number of participating companies has been steadily increasing, indicating growing recruitment interest among companies. The number of visitors has remained relatively stable, but in FY 2025, it increased slightly due to the addition of Fukuoka venue. For the coming year, we are planning to hold the event in Sendai as well, with the aim of attracting students from a wider range of regions. Next, and here's some medium-term initiatives. We provide our outreach lectures where dedicated lecturers visit universities and technical colleges, and these lectures cover energy issues in general, not limited solely to nuclear power. Every year, roughly 2,000 students attend these lectures. We conduct surveys before and after the lectures. As shown in this example, support for the use of nuclear power increases significantly after the lecture, while opposition decreases significantly, indicating a major shift in awareness. Now, I will move on to our long-term initiatives. To stimulate interest in nuclear energy among junior high and high school students, we organize visits to university nuclear research institutes and member companies where students can learn about nuclear energy and radiation. It is also very important to help teachers who educate these students gain a better understanding. For this reason, we organize tours of nuclear power plants, as well as university reactor experiment and training programs. In addition, we encourage teachers to apply what they learn in their own school classes. To encourage broader thinking about energy, we have also developed a board game called Electronation in collaboration with Tohoku University. Through gameplay, participants can learn about the energy mix. It's been used in school classes and corporate training programs, and has also received positive feedback from general board game enthusiasts. We also provide information for the next generation through our website. So that's what we're sharing. For example, we publish content such as Dakara Genshiryoku, where experts and young professionals talk about nuclear power, and Reiwa Nuclear Employee Encyclopedia, which introduces young professionals working in the nuclear industry, and we are continuing to develop and disseminate such content. So far, I've introduced our activities, but looking ahead, I would like to discuss possible future directions. To attract more talents into the nuclear industry, public understanding and trust from society are essential. Therefore, we believe it is necessary to further strengthen initiatives for promoting understanding and developing human resources through collaboration among industry, government, and academia. As a framework for such collaboration, there is currently the Nuclear Human Resource Development Network. It consists of 83 institutions from industry, government, and academia. JIFE serves as a joint secretariat together with the Japan Atomic Energy Agency, JAEA, and JICC. Activities are being carried out in accordance with the Nuclear Human Resource Development Strategic Roadmap shown on the right. This roadmap is reviewed every 3 years, and the coming year will be the time for the next revision. We intend to revise it in a way that will further advance collaboration among industry, government, and academia. As one example of initiative where such collaboration could be effective, we propose creating a platform for the outreach lectures. Currently, various organizations independently conduct outreach lectures. An idea is to integrate these activities into a common platform. Through collaboration among industry, government, and academia, we expect this could help standardize lecture quality, increase the number of participants, and secure new lecturers, thereby expanding and improving the efficiency of those outreach lecture program. Finally, this is a brief announcement. So the JIFE annual conference will be held on April 14th and 15th. The theme this year is Human Resource Strategies Supporting the Maximum Utilization of Nuclear Power. So since the discussion will focus on human resource issues, we sincerely hope many of you will participate. Thank you very much for your attention.
Thank you very much. Now I'd like to invite Mr. Manabu Okazaki from Yonden Engineering, who's the Executive Officer and General Manager of Nuclear, and also from Mitsubishi Research Institute, Inc., Mr. Masaki Kawai, who is the Senior Research Fellow. Thank you very much for your kind introduction. I am Kawai from MRI, and I'm joined by Mr. Okazaki of Yonden Engineering, and we'd like to talk about how we are trying to offer skill of the craft training program for manufacturing. And so the government actually published their guideline, and they talked about the importance of the human resources development, and particularly the field skills. And so we would obviously need to make sure that we utilize our existing reactors and build new ones, and therefore human resources are essential. For example, France is organizing this in a very systematic way, and we're also trying to learn from that. So what we're doing, we are actually offering a different type, various types of courses. So we're working with vocational schools and industrial high schools, and we also involving vendors and suppliers to add the nuclear-specific portions to provide courses, including hands-on. So it's not just classroom training, and because there's hands-on part, the participants are actually quite engaged. So this is a list of the courses that we are organizing this financial year, and we are enlisting the help of various companies, and we are offering different disciplines. And so them are for high schoolers, those in vocational high schools, or we are offering courses, some of those who are already in their mid-career. And the surveys actually give us a very high response, and I'd like to just share with you some of the comments in the free-form fields. And some appreciate that, appreciate meeting people who are actually really working in the field, and good opportunity to think about the future or the future job for Korea, and got more interested in nuclear because they now understand that nuclear is important. And so it's interesting that this actually stimulated interest in nuclear energy itself. And we also heard from the host companies. So for the host companies, they can engage better with schools and the students, and it also helps the industry base, and it also teaching experience actually helps solidify the skills and understanding of the workers who they sent as lecturers. And these are voices from the host companies like Kuri, Halant, and TVE. And one comment says that it's a great opportunity to provide students with early exposure well before they dive into serious career exploitation. Or others say that it's a very motivating and skill experience, enhancing experience, and allow for people to think about possible entry into that industry. And now I'd like to give the floor to Yonden Engineering. Thank you very much. This is Okazaki from Yonden Engineering. So I'd like to talk about the lectures that we offer. So our people actually visit schools. So it's like a visiting lectures and hands-on training. And so we did that for welding and NDE for vocational schools and industrial schools in Ehime Prefecture, which is a local area. And so it's about the principles of nuclear and welding and NDA, the principles and techniques. So for welding, we obviously looked at TIG welding. We looked at the proficiency level, etc. So we started with using the torch and sometimes bead on plate welding as well. And we then used the test pieces for NDE and PT. And so we had that our instructors, or meaning our workers, conduct that. And then we also invited those students for a tour to the Ikata nuclear power station. So they went to a visitor center as well as the site itself. So this is them at the visitors center. And then the response from the survey, the satisfaction level was quite high, and the level of understanding, more interest in manufacturing and skill work. You can see all the numbers are high. And the comment says that they thought it would help their choice of their career, more interest in manufacturing, more interest in nuclear, and very interested to work there. And another comment says that it was a great opportunity to really hear directly from people working in the field. And some asked for more to happen. So I think there are four key learnings from that. So the site visit to Ikata actually helped people to think more about energy and environment. The second point is we offered opportunity for TIG, welding, and NDE in a more real field environment, which is difficult to provide in the schools. And the third point was that for us, we were able to get in touch directly with the students, and we were able to learn what students are thinking when they think about their career choices. And we also were able to hear from the teachers, and that was also good input for our hiring activities. And it also helped us build better and closer relationship with schools, so that led to more interest in our internship programs or company briefings for new hires. Thank you.
Thank you. Last but not the least, from Hokkaido Electric, Kenji Sogahata from the Nuclear Division. Thank you. Sogahata from Hokkaido. I will describe our visiting lecture series for universities and technical colleges carried out as part of our outreach program. So there are 2 universities and 3 technical colleges that are part of this program, as well as where Tomari plant is located. For Tomari, we are to restart with Unit 3, and last year the governor of Hokkaido indicated his support for the restart. So on Unit 3, we will make sure we complete all the preparation so that we can restart as early as possible in 2027. For Units 1 and 2, they are to restart in early 2030s once Unit 3 restart is way underway. As for challenges of securing nuclear power personnel, it stems from the fact that young people, the birth rate is declining, young workers are declining in number, and the number of applicants to the nuclear area is declining. So with regards to securing recruitments for nuclear, as we expect more people will be needed to get ready for restart and a new construction, we need to secure more people. So we felt that we need to go outside of Tomari plant to have direct access to future workforce. We also thought that it is necessary to promote people's understanding on nuclear. And thirdly, we thought that we should be contributing to community in terms of human resources, so as to contribute to the local economy and community. So based on those understanding, we are actively providing visiting lessons, lectures at colleges. So for this fiscal year, we have provided lessons 30 times with a total of 806 participants. And METI expressed interest in our program and offered their materials as part of the materials to be used in our lessons. So I'd like to give you the overview of our program as well as how we are using the materials from METI. This is the overview of lectures. We have 2 full-time employees working on the programs. And based on the relevant subjects, we request cooperation from other divisions as well. And we are giving explanations to the students so that they can get a better understanding of what's in the textbook. And we also are drawing on our own experience to supplement the information in the textbook. And it is important that we get people's, students' intellectual curiosity. We started the program in 2011 at Muroran Institute of Technology, and in 2007 we added 4 technical colleges and Kitam Institute of Technology in 2023. This is an example of the education materials that we use. The textbook explains fast neutrons and thermal neutrons in nuclear fission reactions. And in our lecture material, we incorporate time factors into the fission reaction. And also, Hokkaido is home to the 2 towns where a literature survey on high-level radioactive waste disposal site was conducted. So we included relevant information on this in our classes as well. Now, some comments from the students and faculty members. They were all very positive. And for nuclear program itself and the content of the lecture itself are well appreciated. And of course, that encourages us to do even better. Now, I'd like to talk about our collaboration with METI. On the left-hand side, you can see the materials on fast reactors prepared by METI. On the right-hand side is the materials that we developed by recompiling the content of the METI material. The METI material is very easy to understand and have a very concrete and very articulated text. And we re-edited that. But the way METI material is edited enabled us to rearrange very easily, and therefore we were able to save our work in preparing the materials. And those materials were really effective in getting the good understanding of the students. So they were very useful. As for our future initiatives, we would like to build trusting relations with the educational institutions so that we can have access to the people who will be interested in working in the nuclear industry. And we would like to contribute to the community activities and the industry through our program. Thank you very much.
若干時間をしており
Thank you very much. We are a little bit behind schedule, but we would like to have a brief discussion among the panelists. We hope you can help us reduce time. So first, I'd like to ask Watanabe-san from NRA. So you talked about working with external agencies and utilizing various people and also looking at fluidity of people. So after listening to all the presentations, any observations? Thank you very much. So from session 3, I only joined from session 3, so I may have missed the earlier parts. But human resources is really important part of the supply chain. I was really reminded of that, and particularly with regard to people on the regulatory side, who's also responsible for safety. That is also an important part. I hope people will appreciate that too. We will try to be proactively part of the discussions. Earlier the discussion that NRA isn't really sitting together with Agency of Natural Resources and Energy, but we can be present at these occasions. And our Chairman Professor Yamanaka says that human resources is a common issue. It's not about regulator and regulated. So we would be very open to work together where we can. And earlier, JIFE talked about nuclear and getting younger people to nuclear. And we hope that we can work together because that helps us too. Thank you very much. We appreciate that positive message. So I'd like to ask Wada-san from JIFE. You talked about the Nuclear Human Resource Development Network and the review of the roadmap. So could you perhaps remind us about the objective of the review of the roadmap and what that means? Yes, thank you very much. This roadmap for the nuclear human resources strategy. This was actually established in 2014, and 10 years had passed. So in FY 2023, we had revised that. And we decided to look at the 10-year time frame. But then given that the strategic energy plan is reviewed every 3 years, we decided that the roadmap should also be reviewed every 3 years in tandem. And therefore, in FY 2026, we will be revising that roadmap. So last year, the 7th Strategic Energy Plan came out, and they talked about maximal use of existing reactors and new builds for advanced reactors. And to respond to that, we will need to prioritize the measures we decide on who's doing what until when. So we would like to make this roadmap even more effective and practical. Thank you very much. Aibaya-san from MEXT, you talked about the importance of working with the industry in your presentation. So anything you want from the industry, any challenges? Thank you very much. So in this discussion today, we heard from the Yonden presentation that the students were really thinking seriously about their career options and more interested in joining the nuclear community. And so ANEC is also conducted some surveys, and we heard similar responses. So when we think about the future of ANEC, it's very important to liaise stronger with the industry. So we will really take that into heart as we think about the next steps. Thank you very much. Thank you very much. Okazaki-san from Yonden Engineering, I'd like to ask you this question. So you talked about all your initiatives, and I hope that will really expand and become bigger and available nationwide. But I'm sure you are facing some challenges to do that. Anything that? Yes. From experience, we're talking about this high-level welding and NDE. And it's really difficult to communicate the really high level of quality required for nuclear. That's the challenge. So that's why we're working with Shikoku Electric Power and added site visits to Ikata Nuclear Power Station so that you can see for yourself the real operation. And we believe that that actually helps deepen the level of understanding among the students, and so therefore be more effective. And we are trying to offer this for more schools. But, for businesses to approach schools, sometimes they are not so open to businesses. But the thing is that if this is a government program, the schools are more open. And they have more confidence in us, and so we are getting better responses. So we hope that this cooperation among academia, government, and industry continues so that we can enhance our human resources development. Thank you very much.
Next is Kawai-san from MRI. The initiative that you talked about today, I understand, has been conducted on a trial basis since 3 years ago. So what do you think are the future direction based on your experience? Yes, through the 3-year experience, I think we have been able to expand and improve both in terms of scope and quality. What we can do differently is maybe for the high school students and the vocational school students who have wide options as their future career, maybe the programs could be provided not on individual company basis, but more on the industry-wide collaboration basis. I think that would provide better opportunities for everyone. And worker shortage is a common issue for everyone in this industry. So as ENRI representative mentioned at the beginning, I think collaboration would be needed. Thank you. Sogahata-san from Hokkaido. To develop what you shared with us today to an industry-wide collaboration, what is needed? Thank you. Where we can collaborate on an industry-wide basis would be the sharing of the lecturers as well as information sharing. And JIFE presentation included building a platform. And I'd like to comment on that. To secure new lecturers, I think it would help us if we can build a platform or a system where we can share such resources. I think that will resolve the issue of resource shortage, and I think it would contribute to stabilizing the quality, the uniform quality of the programs. So I think that would be very good. And that would also contribute to the labor saving in developing the training materials. So that's another area where we can collaborate. So I'm hoping that the platform will be built on an industry-wide basis, and we are more than happy to help in what little way we can. Thank you. Going back to Wada-san from JIFE again. So initiatives are being driven in different sectors, industry, government, and academia. What is the role to be played by JIFE as an industry organization, do you think? As mentioned earlier, to secure personnel for nuclear, we need the understanding of the people and social trust, public trust. For that, we need to have a collaboration amongst all three sectors to steadily implement necessary measures. JIFE will continue to work with the relevant parties in such areas as JIFE school visits, the lecture series, as well as providing information on next generation people, so as to promote the understanding of the people. Thank you. Ideally, we should be asking for your inputs for another round, but I'm afraid our time is up. So let me conclude by saying the following. I think the key word is the breadth. In other words, to have an expansion. So the seeds are sown, and we are seeing the buds of various initiatives. Worker shortage is a real issue. And therefore, the government, academia, and industry need to work together. Starting today, the government would be providing necessary support for this. And with that, we conclude session 4 I'd like to thank all the members of the panel. Thank you, Tada-san and the panel. Please join me in giving them a big round of applause as they return to their respective seats.
Finally, we will have closing remarks from Mr. Hideki Masui, Chairman of the Japan Atomic Industrial Forum. As introduced just now, I am Masui from Japan Atomic Industrial Forum. So I want to take this opportunity to give you closing remarks as a co-host. So there's been accelerated efforts to the next generation of reactor after the 7th Energy Basic Plan decision made at the Cabinet last February. So there's been the exchange of information views with Nuclear Regulation Authority and a voluntary resumption of on-site service for successor units at Kansai Electric Power Mihama Nuclear Power Station, and announcements by nuclear manufacturers to expand hiring. So now this fourth symposium has also been highly significant. Parliamentary Vice Minister Komori delivered a strong message on nuclear power. From Mr. Kume from the Natural Resource Agency, delivered explanation about the nuclear policy, which is crucial for business outlooks. In the subsequent session 1, themed the future of the nuclear industry, the valuable insights were shared. Mr. Kito, chairman of the Resources and Energy Committee of Japan Business Federation, Keidanren, presented the necessity and expectations for nuclear power from the business community perspective. And Ms. Simon from Amazon Web Service highlighted the significant international expectations for nuclear power as a reliable source of decarbonated electricity. Especially, I was quite impressed by this company about the support provided by this company for the energy conversion in Japan, transition in Japan, and that was quite impressive. In sessions 2 introduced the steady progress of development project as companies advance efforts towards developing and deploying next-generation innovative light water reactors. It was also reaffirmed that utilizing government-supported GX project subsidies for technological development is essential, and participation in export project is indispensable for maintaining and strengthening competitiveness for future domestic new construction. Session 3 focused on supply chain strengthening initiatives, suggesting the need to accelerate efforts through industry-wide coordination and appropriate role allocation among utilities, manufacturers, suppliers, and related organizations. So it was emphasized that presenting a concrete outlook and future vision for nuclear power generation aimed at continuous and zero development and installation over the mid to long term, and is essential for future plant replacement and for rebuilding the supply chain technology. And so basically showing the actual future image for the nuclear power supply chain was very important, and that was emphasized. In the final session 4, they introduced different activities for securing and developing human resources. And so securing and developing human resources to support maximum utilization the nuclear power. I think this would be quite important to bridge the human resources to the future. And this is the challenge to be addressed by the three parties in the government, industry, and academia altogether to ensure enough resources to support the nuclear power. And I think, again, the coordination among the stakeholders were quite important, and I recognize that importance. And I really appreciate many participants today, including the presenters and the panelists. And also thank you very much for the related party to prepare for this symposium for the last few months. And I hope this symposium serves as a catalyst for new actions and contributes to future further strengthening supply chain. Thank you very much for joining us today. Thank you very much. This concludes the 4th Nuclear Supply Chain Symposium. For those attending in person, a survey will be sent to you by email. We would appreciate your cooperation in responding to the questionnaire. For those joining online, a survey will appear after the session, so we would appreciate your cooperation in completing the survey. When you leave this venue, please return the simultaneous interpretation receivers to the registration desk. So thank you very much for your participation today.